Yo, welcome back to the Southeast Welding Academy. My name is Wisdom Shapard. I'm your AWS certified welding instructor, and today in this instructional lab video today, we'll be going over your root pass, right? So this is week 5. This is week 5, episode 2, okay, on your root pass, right? All right. So today, excuse me, I'm still getting ready. So today we're going to be doing a root pass on your T-bar, okay? And then we're going to go over some things, involving the root pass, why you want your root pass to be a great root pass, you know what I'm saying? We're going to go over penetration, root pass penetration. We're going to get to why you don't want to leave undercuts and really all your welding impurities inside your root pass, right? And why, you know what I'm saying? We're going to talk about why your root pass is so crucial, you know what I'm saying? Why your root pass is so important, okay? Then I'm going to show you guys how to conduct the root pass, okay? These are cool, these are not happy. We just gonna use this T-bar, okay? So with this T-bar, we got 4 sides, right? 1, 2, you got 3, you got 4, okay? That's 4 sides to practice in, right? So we're gonna run 4 hat passes. 4 root passes, right? And I'm gonna show you guys what you wanna see. I actually run about 1 with that you don't wanna see. I'm gonna run 1 root pass, okay? Filled with welding impurities and defects. So you guys see what you don't want your root pass to look like, and I'm gonna explain why you don't want your root pass to look like that. And then I run, the last 3 properly, so you guys can see the features of the root pass of what you want to see. You know what I'm saying? And what you're looking out for when you're conducting a root pass. Okay, so amperage, right? Usually, okay, so your amps or your welding current should be set to your position. You know what I'm saying? So where it's vertical, you'll probably running at like 120, but for flat, you'll probably run at, 115 or vice versa. You know what I'm saying? But moral of this comment is your amps will obviously be set to your workpiece and the type of material, the thickness, and what type of metal it is, you know what I'm saying? So also your travel speed. It's a lot of factors and what your current should be set to, you know what I'm saying? But I forgot what I was saying. Overall, what I was just trying to say was usually you'll just want to make sure that you're not running too cold when you're running the hot pass, because if you're running too cold, you will have a lack of fusion, you know what I'm saying? The complete mixture between the metals and your filling metal, you know what I'm saying? You will have a lack of fusion, and you can also have a lack of penetration. But you don't want to run too hot, because you can also get an excessive amount of penetration or excessive amount of bloatage, you know what I'm saying? It can also be dripping over because it's too hot, you know what I'm saying? It's building up too much. Yeah, those are a couple of things that you want to look out for when you look for your current and your travel speed, right? Or really your current. We were just going over current, okay? So not too hot, but definitely not too hot, and definitely you don't want it cool, okay? I don't think I'm going to be doing any editing in this video, so y'all just going to see the raw uncut. Look, I'm dropping my gloves. You know what I'm saying? I'm dropping my gloves. want to see the raw and uncut. All right, so me, I like to do my root pass. I like to run my root pass hot. Okay, hot meaning 120. All right, that's me. Why? Because when I run hotter with my travel speed, you know what I'm saying. You also gotta set it to your travel speed. But when I run hot, it's easier for me. It just works with my travel speed, and I get more fusion, you know, faster running at 120. Okay, that's just me. Okay, it's easy for my travel speed. It works with my travel speed. Okay, I get the complete fusion, so I leave no undercut, and I also get complete penetration. You know what I'm saying? But I'm also not getting excessive penetration. It just works for me. Find your current that works for you. I know some people that probably run their high pass at 116. You know what I'm saying? At 115, at 112, at 100. Okay, but not too low, like 90. You know what I'm saying? That's too low for these 1.8 rocks. Maybe if you was using 332, 718, 332, you could run 90 on the high pass. But these 1.8 rocks, you got turn that baby on. Alright, so right now I'm just tacking my wheel down. Okay, boom. Alright, now let me show y'all what exactly I'm doing. Okay, hold on, I'll be right back. I need to find me a chip and hammer. Hold on. Alright, we just gonna ask the student for one of hers. I mean, if we could borrow hers. Actually, I'll just do it. Alright, what I am gonna do is I'll brush this off so you guys can see clear. Okay. Look at this. Okay, so with my root pass, right? First thing you want to do before you start welding is you want to know where your weld metal is going, right? And what you're doing, okay? So your root pass is the first pass in a multi-pass welding process, right? So in this case, if I was really doing full potential weld on these T-bars, I would be doing my root pass, my hot pass, and my 3 stringers, right? That is a multi-pass weld, okay, process, okay? So my root pass will be, it's just like a tree, right? Your roots, how it keeps the foundation nice and strong, it's just like that, okay? It's the same concept. Just think of that concept when you think about the root pass. You want your root pass to be nice and strong, nice and straight. Your root pass just sets the foundation for every other pass, okay? If your root pass is filled with impurities and welding defects, then when you cover it, you know what I'm saying? For example, if you leave undercut, you know what I'm saying, in your root pass, or you leave porosity in your root pass, then that can cause gas bubbles or gas pockets to be under your hot pass, you know what I'm saying? Which can also cause your weld to start breaking from the inside. That's internal damage, okay? With a weld, you can have impurities inside your weld and also outside your weld. This is why you want to pause and get the complete fusion, you know what I'm saying? You want to keep your puddle, you want to make sure you're not getting undercut. You want to get a complete fusion between your metals, okay? As you're going up, okay? You don't want to leave any impurities. So with the root pass, what I'm going to do is I'm striking down, boom, and I'm bringing my puddle up to this corner, right? When but what I'm doing is I'm not sitting exactly in the corner and just taking it straight up. I'm hopping straight from wall to wall, okay? And I'm not hopping boom, boom. Well, I'm keeping it in the corner. So it'll look like boom, pause, right here, pause. You know what I'm saying? Right here, pause. This is my oscillation method, zigzag. So I'm going straight, then I'm going up, diagonal, pause, then I'm going straight, pause, diagonal, pause, just like this. These are restarting methods. You got the 6 method, right? I'll show y'all that when I have to restart, okay? Let me show y'all this real fast. Now I am sorry that y'all can't see exactly what I'm saying, you know what I'm saying? But I just showed y'all the overall concept. in the future, you guys will be able to see what I'm welding. What I'm saying, you guys will be able to see what I'm saying. You know what I'm saying? So you guys can understand a little bit more. But everything that I just said, I'm doing exactly what this oscillation method is what I'm doing. I'm bringing my rod, and when I strike my rod, I'm coming straight all the way down on this backing strip. Then I'm bringing it to the corner, and that's when I start my oscillation method. Right here, pause, straight across, pause, diagonal, pause, straight across, pause, diagonal, pause. That's my zigzag oscillation right there. Okay? Remember those pauses because you need to pause, okay? Pausing helps you get the complete fusion without leaving any undercut, you know? On the toe of your wheel. Right now I'm cleaning my rod. There you go. Gotta clean my rod a little bit, that's all. Clean it on here real quick. Oh, I did it looking like a rookie. No, I don't like this rod. I don't like that rod. You know what? We're gonna take that. We're gonna take that as a lesson right there. And I'm gonna use that restart. I'm gonna just show y'all how to restart now. Since I decided to sit. Hold on, give me a second. Alright, had to borrow the chicken hammer. Because I gave it to a student and it is. I think they took it with them. Alright, my bad. Let me show you guys what this looks like. Okay, so you see that little bit of undercut? Right there down on the groove. You see that little bit of undercut? But overall, got most of the complete fusion, you know what I'm saying? On the toes of the wheel going up. This is a strong root pass, okay? And if y'all can't tell that now, I'll show you guys what a bad root pass look like, okay? In a minute, just give me a second. Okay, so these right here are our restarts, our restart methods. So the oscillation method is right here. The restart methods are right here. But the restart methods and the oscillation method is right here. So this is what I'm doing. Okay, if I use the 6 motion, this is what I'll be doing. I'll do the 6 motion. Then I'll go back to my oscillation. Side, diagonal, side, diagonal, side. If I did this restart right here, which is just coming down to the low part of the crater, doing a quick step back to the high side of how do I say this? You're at the low spot of the crater. You strike your rod at the low spot of the crater. You do a quick step back motion to the high spot of the crater. Come back to the low spot, hit the left side, pause, then hit the right side and pause real quick, and then go back to your oscillation method, which will be, in this case, all right, I strike down, come to the low side, low part, high part, I'll go to the high part, come back, left, right, then I will go back to my zigzags. Boom, straight, diagonal, straight. You know what I'm saying? And this is just circles. You'll come down, do a couple circles, and then you'll go back to your oscillation method. All right, so right here, I'm gonna show y'all the 6. Okay, I'm gonna come down, I'm gonna loop it like a 6. I'm gonna hit it, and then once I complete the 6, I'm hitting my left side, pause, right side, pause, then I'm going back to my oscillation method, which is my zigzags. Now let's do that. This is the 6 motion, y'all. I'm doing the 6 motion. Then I'm hitting that left, right, going back to my zigzag. Let me go get a chicken now. Alright. See how look, I kept it the same time. It looks smooth all the way up. You know, it could be a little better if it just come from. I could have been pausing a little bit more, taking my time. My plate set, you know, it's not set to my like it's like set to my liking, but I could bring it down a little bit more. I peep as I'm going up. I'm getting unsteady a little bit, and that will cause I'm trying to rush the wheel a little bit. But let me point out what you guys will see. So you see that little bit of undercut? You know what I'm saying? You still want to watch out for that undercut. I didn't get it all the slag off, so but it's probably most likely undercut, a little bit of undercut on that side. Y'all see the bead is the same size all the way up. The bead is the same, meaning the same width and height all the way up. It's the same, what is the word? The same pattern going all the way up, kinda. You know what I'm saying? This is a nice strong root pass, but it still can be better, right? Our next one, I'm gonna try to be better on the next one, right? You see the undercuts on the sides. Okay, you got a little bit of porosity, or you get a little bit of porosity in places. Okay, but overall, this is how you want to run your root pass, right? So that way, if your root pass is straight just like this, that way when you put your high pass on top, because remember, it's the first pass in a multi-pass wheel, right? Once you put if your root pass is straight, nice and straight like this all the way up, your high pass will be straight. And if your high pass is straight, your strangles will be straight. If your root pass was crooked, your high pass gonna be crooked. If your root pass got low spots and high spots, then your high pass will also have low spots and high spots. That's why you want to make sure your root pads is nice and clean, nice and strong, and nice and it just looks, it's not like just it's just strong, you know what I'm saying, uniform, straight. And yeah, you got the complete fusion. It's strong, it's uniform, then everything else should be strong, uniform, and yeah, everything else should be set in place. You gotta remember the root pass is the first pass, meaning this pass sets up everything. If your root pass is bad, everything else will be bad. It's the foundation of your multi-pass process. The root pass is the foundation. Okay, if your root pass is terrible, everything else will be terrible. Okay, straight like that. All right, so now we're gonna take this off and we're gonna run another hot pad, another root pass real fast. Rushing because I gotta help my student out before I clock out. You know? I want to make sure I get with my student. Make sure he on the right road. So we got one example. Now I'm gonna show you another example. I was just complaining about my height, the height of my workpiece, but I just work through it. Even though that's not what I should be doing. I shouldn't be working through it. I should be fixing it to where I'm touching it. So now I'm doing the same oscillation method, the same zigzag method, okay? Coming down, what I'm doing, I'm striking my rod down all the way to the backing strip, to the bottom of the backing strip on this side, okay? And then I'm bringing it up to the corner, and I'm starting my zigzag motion, right? Keeping my rhythm. It's all about your rhythm. Once you know what you're doing, you're just carrying out your rhythm. I don't have a chipper hammer, so I'm not about to keep going back and forth to chip this. You know what I'm saying? I do know a way to prevent the slag inclusion, you know what I'm saying? Or I do know what I'm doing, I can still see my crater. Usually y'all want to break this off, clean it, and then restrike, but I'm just gonna go back in. I'm doing the same 6 motions restart, okay? Alright, hot pass number 2. Back it off real quick. Hot pass number 2 looking a little better. See, overall, you just want that nice uniform look with minimum undercut, minimum defects on the sides, you know what I'm saying, in the middle, all of that. You just want minimum undercut or minimum welding impurities, period, when you're welding. This is for every weld, though. This is for hot pads, roof pads, stringers, every type of weld you will want. Minimum welding impurities, okay? So you see what I did better on this one, you see less undercut. I took more time on the sides, you know what I'm saying? It's still nice and straight, so if I run a nice hot pass on this, I could just follow the toes of my wheel all the way up, and my hot pass will be straight, okay? Boom. Alright, so before I flip this this T-bar and I do the other 2, okay? The other 2 hot pass, roof passes, what I want to talk to you guys about, these 2 right here are still considered good roof passes, right? They got good penetration. I know this because of my current and how much time I was taking. You know what I'm saying? And my puddle getting the complete penetration okay. I got minimum undercut on the sides. I have minimum porosity. I have minimum. I really don't have everything that you see could be grinded off. Okay. So the little porosity that I have could be grinded off with a grinder. Okay. So that really won't hurt. I don't have any porosity in my wheel. Okay. So these are 2 great 2 good hot passes. You know what I'm saying? Consider 2 good hot passes. They're nice, strong. They will hold the integrity of, you know what I'm saying, whatever. If I put a hot pass and some stringers on top, I will have no doubt that there wouldn't be no gas pockets or in the inside, no cracks on the inside with these 2 roof passes. Okay, so I'm gonna run the next 2 roof passes bad. Okay, what you want to look out for when you run the roof pass is your width. Okay. If your width gets skinny and then wide and then skinny, that's a bad roof pass, okay? Why? Because it's still the foundation. Your roof pass is the foundation. So if your roof pass is all not uniform and it's all wide some places and skinny some places, maybe low some places and high some places, when you put your roof pass, when you put your hot pass on top of your roof pass, okay, you will still have your low places, your high places, you will still have what else did I say? You will still have your wide places and your skinny places. You will still have this, okay? So watch out for your root pass width, okay? You want to keep it the same width and the same height all the way up, okay? Another thing you want to worry about is your undercut, okay? Make sure you're pausing on the sides, okay? So you're getting the complete fusion in between your metal, the complete mixture of your metal, okay? Of your metal, right, and your electrode, okay? So just focus on that rhythm, okay? Another thing, don't burn too hot, don't burn too cold. You burn too hot, okay, you'll get more burn through, maybe excessive penetration, and you'll get more porosity. You know what I'm saying? Depending on your travel speed and your oscillation speed, you could get more undercut. Okay, if you're running too cold, you'll have trouble with sticking your arc. You know what I'm saying? Your arc will always be sticking. You'll have trouble keeping your puddle alive. If you do run if you do finish welding a complete bead running cold, your pattern really wouldn't be all put together just like that. It would be more kind of choppy, you know what I'm saying? And I'll show y'all a bead where it was running too cold, you know what I'm saying? I'll show y'all that. Travel speed with the root pass, you want to make sure you're taking your time and pausing, you know what I'm saying? You know what I'm saying, on the sides. You want to make sure you're never leaving your puddle, okay? You leave your puddle and you'll get undercut or a lack of fusion, okay? So you want to just take your time, find your rhythm and your root pass going all the way up. Just like a regular stinger bead, how we practice welding vertical, just like so on here, okay? Just find your rhythm and take it all the way up, okay? Yeah, that's all I can think of right now. Alright, so right now y'all watching me tack my plate. Okay, so y'all see how my root passes came out when I ran properly, you know what I'm saying, to my liking, or to my setting. Now I'm gonna bump it down to where it's kind of too cold for me to control. And we'll see the difference in the undercut, you know what I'm saying. We'll see how many times I stick the rod. We'll see the undercut in the end. We'll see what my weld bead just looks like overall compared to what I previously just welded. I'm cleaning my rod. This isn't nothing right now. I'm cleaning my rod. Okay, now my rod is clean. Like I said again, I'm just gonna restart because, you know, I don't have a chipping hammer right now at the moment. But I know what I'm doing. Usually y'all would chip it off, clean it, and then restart, okay? Okay, but I know what I'm doing. I can still see. I know where the crater is, I know where the low spot is, I know where the high spot is, so I know exactly where to have my rod. But another thing is, even if you know what you're doing, you still should chip it off. Just like now in this situation, I still should chip it off due to I can get slag inclusion, okay? But right now, I'm just showing y'all for the matter of me not wanting to waste time to go to another booth and ask somebody for their chip, or ask one of the students for their chip. that they are currently using, okay? So I'm gonna do the 6 motion and go back to my oscillation method, which will be the zigzags that I showed you guys. Oh no, guys. See, that's what happens when you run too cold. You gotta restart and be in that puddle for a little minute. It's too cold and you're running in that puddle. Being in that puddle for too long, you'll start to stick to that puddle. See? That's where you get annoyed at. So I'm trying my best to get the complete fuse in still before. I can see me get a little bit of undercut. Making sure I pause on my side. Trying to get as much complete fusion as I can. But see, I was trying, hold on. Okay, this one is bad. Give me 1 second. Let me show y'all this real fast. Alright, I was gonna run 2 root passes with defects in them so I can show you guys. But I think I'm only gonna have time for 1 because I need to get in this booth with one of my students. But this is prime example of what happens when you run too cold. It's got a couple of welding defects in it. Alright, so boom. Y'all see how it's kind of uniform, but look, you see how you get this bump right here? The small, even the small bump. These bumps right here, you see how it kind of gets wide right there? Okay, and you still got these bumps. And up here, it looks kind of flat. Also, you have undercut all throughout this wheel, okay? No matter how long I tried to sit on the sides, some places you see less undercut. I was taking my time on the sides, but sometimes it wasn't not enough, okay? Let me put you guys on to a couple things. When you're running cold, right, your bead can come out flat just like so, right? That's what happens when you're running cold. Also, you have to, when you're running cold, you have to sit on your, you have to pause for way longer to get the complete fusion, meaning let your puddle catch up to your rod. If you're running colder, right, or say, I ran colder, I ran this hotter, you know what I'm saying? So you guys see the thickness, how much weld metal was being deposited versus this when I was welding colder. You can see the pattern isn't really all together for real. It's kind of chopped up. You get the undercut, you know what I'm saying, for the lack of fusion. Also, when you run cold, you also have a higher risk of getting a lack of penetration to the other side because it's, you know, it's just not hot enough. And then you see these wide spats, this wide spat, and you see some low spats and some bumps. So when I put a root pass on top of this, whereas if I put a root pass on top of this nice clean wheel right here, which is the same pattern all the way up, you got no bumps in them, it got no low spats, it's the same height and width all the way up. This one is not, okay? This one is different widths, different heights, you know what I'm saying? You can see the bumps, okay? If I put a hot pass on top of this, wherever these bumps are, my hot pass will have bumps in them, okay? Wherever the low spats are, or the spats that I have to fill in, my hot pass will be low right there, okay? Yeah. These are our oscillation and restart methods for this root pass. for our root passes that we ran today. Okay, we did the zigzag oscillation, which is side, pause, up, pause, side, pause, up, pause, side, pause. Okay, these are our restart methods. We use the 6. We use the step back method. Okay, come back up, left, right, and continue to go up. And then we got the circle method. Right here today we use the 6 method, okay? So that's all for this video today. I hope you guys learned something today. I hope I can teach you guys something today in this video on restarts, you know, the importance of your root pass, what you want to look out for your root pass, how your root pass, how you want your root pass to look, and what you don't want to see on your root pass, okay? I hope you guys learned a little bit in the video today. This is week 2. This is week 5, episode 2 on root passes. This is the Southeast Welding Academy. My name is Wisdom Shapar, and I'm your AWS certified welding instructor. Yeah, I'm gonna see y'all in the next one.